We're good to go.
Good afternoon. We're very fortunate today to have in our presence 5 folks who were very involved in the design, development, and testing of the Aerostar during its early days and during production. I'm going to introduce each one, and then following the introductions, I'm going to ask Dick Reese to say a few comments to set the stage about what it was like working with Ted Smith in the very, very early days of design and development. And then following that, I'm going to ask the panel to answer some questions to kind of get everybody thinking in terms of asking questions. And then we'll open up the floor for questions. So starting on your left, I'd like to introduce Dick Reese. Dick was the Director of Engineering, and next to Ted, Dick was the person most responsible for the design of the Aerostar. Dick was the most senior engineer and reported directly to Ted. Ted relied heavily on Dick's expertise and greatly respected his engineering and engineering management skills. As the manager of the overall design effort, Dick was involved in virtually every aspect of the design. He worked well with everyone and was diplomatic and effective. He was highly respected by the entire engineering staff for his technical abilities as well. In addition to having overall responsibility for the engineering design effort, he personally designed the nose of the plane, the gear retraction and extension system, including the sequencing linkage and actuating mechanisms, the main landing gear, including the side braces, power plant to airframe interface, cowling and nacelle, elevator trim system, electric nose wheel steering, and fuel system. He also served as the FAA Designated Engineering Representative, DER, for the power plant and systems. Dick, along with Ted, were awarded a patent for the Aerostar main landing gear and a patent for the Aerostar electro-hydraulic nose wheel steering system. Dick also received an FAA safety award for the on-off design feature of the Aerostar fuel system. Dick also advocated and was responsible for adding eyebrow windows above the pilot and co-pilot to provide excellent visibility in turns, especially in the landing pattern. The openness and trust between TR and Dick reflected an excellent rapport between the two men. Dick received a mechanical engineering degree with an aeronautical option for structures from the University of California at Berkeley, back when Berkeley was Berkeley, in 1951. After college, he attended U.S. Air Force pilot training. He flew the AT-6 at Bartow Air Force Base, the T-28 at Corinne in Texas, and the T-33 jet at Craig Air Force Base, Alabama. His was the first class to earn their wings flying a jet. As a civilian pilot, he flew a Turbo 210 for about 5 years. Next to Dick is Bill Leeds. Bill Leeds was an important part of the Aerostar engineering effort. He started as a structures engineer in 1967 at Northridge, working for Al Astorga, who had taken over for the structures group when Lane Helms departed. Bill relocated to the Van Nuys factory in 1969 to support production of the models 600 and 601. When Butler purchased the company, he was assigned to the model 620 and moved back to Northridge, working for Dick shut down Northridge. When Ted bought the Aerostar program back, Bill was hired by Ted Smith and Associates at Van Nuys. His first responsibility was retrieving and setting up the engineering data system. The FAA also made him a DER for structures. He was appointed manager of structures and technical services, which included processes and technical publications. He continued in this position at Santa Maria. In 1976, he worked on the European certification of the Aerostar for approximately 25 countries, locating himself in Geneva, Switzerland for about 4 months. In 1977, Bill was promoted to Director of Quality Control, continuing in that position after Piper bought the company. In 1981, Piper relocated him to Vero Beach, Florida, where he was Director of Technical Services, which included structures, flight test, and document control. He left Piper in 1983. He then worked for Avtec as Manager of Structures, designing a Canard twin turboprop, and later became Vice President of Engineering. Following this, he worked for Tracor and Jet Cruiser. In 1994, he joined Steve Spears and Jim Christie at Mach and later Aerostar Aircraft Corporation in Spokane, Washington, and later Hayden Lake, Idaho, where he worked on several Aerostar enhancements. Next to Bill is Paul Sterling. Paul graduated from Northrop Institute of Technology with a Bachelor of Science in Aeronautical and Astronautical Engineering in September '68. Since then, he also has done graduate studies at the University of Washington in advanced aerospace engineering and mathematics. After interviews with Boeing, Cessna, and Ted Smith Aircraft, Paul chose Ted Smith. Bill Leeds did the interview for the Ted Smith Corporation. And talking to Bill Leeds, Paul would say, "I was immediately impressed with the company and what they were doing. They offered me a job as a structures engineer." Paul was also drawn to the small airplane business because he had a commercial pilot's license. He went to work at the Northridge Engineering Facility, working for Alice Dorga in structural analysis alongside of Bill, Ken Grosnick, and Fred Nordstedt. His first assignment was working on a fail-safe structure test proposal to submit to the FAA. He was also put in charge of the test lab after Larry Belfer left and did the Model 620 pressurization tests. In another assignment, he took in-flight measurements of cabin noise levels. Paul would say, "I remember sitting in Ted Smith's office explaining how we did the noise testing. It isn't many companies where the CEO invites you into his office to do that. I still count that to have been a real privilege." When Butler purchased the company in 1970, Paul went to work for Lockheed in Palmdale, California, doing analysis of vibration and noise data. When Ted R. Smith and Associates reacquired the aircraft and acquired an STC to pressurize the 601, Paul rejoined the new company as an employee number 70. He was hired to be part of the flight test group, which was then made up of just Boyd Leidick and himself. Paul did flight testing of the customer's airplanes after the pressurization mod was completed. Paul claims he actually has more time flying the Aerostar with just one engine running rather than both. While this might be a slight exaggeration, his extensive single engine time accrued because he performed single engine climb testing whenever a model used a different engine. This was important because certification gross weight is tied to single engine performance. When the Santa Maria division shut down, he was the very last engineer to leave the building. To Paul's left is Glenn Mills. Glenn started working for Ted Smith Aerostar on June 20th, 1977, fresh out of Cal Poly, San Luis Obispo, with a bachelor's in aeronautical engineering. He was assigned, as most new engineers at TSA were, to the liaison engineering group to learn more about the design and production of the Aerostar first. This assignment was spent in the back shops, tooling, subassembly. There's 5 sub-assemblies making up the fuselage, and the wing and tail mating prep and installation. In October '78, he joined flight test, where Monty Kerr was the manager. Glenn would say, "Dan Sloan and I started in flight test the same day. We were originally in the flight shack. We moved to the industrial building Piper rented for engineering, while the new manufacturing facility on the airport was built. The first project under the Piper numbering system I worked on was Project 49, the 602P. In parallel, he started flying in the known icing program with test aircraft serial number 266. He flew flights looking to encounter icing conditions as the flight test engineer, with Dan Sloan as the pilot and Larry LeBeau doing instrumentation. In addition, he assisted in reconfiguring the aircraft flight manual into the new pilot operating handbook format. This included re-verifying performance data to ensure accuracy. Glenn would be the primary flight test engineer for the 700P development flight test program and would move to Vero Beach when Piper shut down Santa Maria. After leaving Piper, he would become an FAA DER flight test analyst for both Parts 23 and 25. A major project was the Boeing 747 conversion to a firefighting air tanker. Glenn remarked, "The Ted Smith flight test job was the best job I ever had. Every engineer at Ted Smith had the opportunity to make a difference." Next to Glenn is Roger Oland. Roger joined the development shop at Northridge in 1966 and worked for lead man Walt Stafford. Regarding the shop personnel, Roger would remark, "Everyone was very skilled and we respected each other. People could do more than one task. Making high-quality parts was everyone's goal, and some would try to outdo the other. Morale was very high." Roger would also become a lead man at Northridge, and as many of the shop people did, helped set up production in the new Van Nuys factory. He also worked on the Model 620 and the pressurization tests of the fuselage. When everyone was fired, when Butler took over, he worked 9 months fabricating and assembling military radar units for another company until Ted called him to modify the 601 for pressurization at Ted R. Smith and Associates. He had told Ted he would like to work for him again and had looked forward to his call. Roger would also be a central person in building the Superstar 700. When the company moved to Santa Maria, he became general manager at Mr. RPM in a hangar at Van Nuys near the former TSA hangar. He would modify 37 Aero Commanders with the IO 720 400 horsepower Lycoming and various associated STCs. Later, Roger formed his own aircraft maintenance and modification business at Van Nuys, naming it Aero Specialties, specializing in Aerostar maintenance and modifications. Roger is a bona fide Aerostar maintenance guru with a pedigree starting from hand building the original planes at Northridge, followed by decades of experience. He has always felt fortunate that he knew Ted on a personal basis. We also have in the audience one other person that I'd like you to be aware of. He's not on the panel. His name is Fred Nordstadt. Raise your hand, Fred. There's Fred. Fred was an aerodynamicist responsible for determining aerodynamic loads on the airplane structure and some shapes. Because his aero loads data would determine the design of structures and other materials, he worked closely with and sometimes assisted Lane Helms performing stress analysis. He accomplished aerodynamic load reports required for FAA certification and assisted in writing several stress analysis reports. He determined the NACA scoops in the nose of the 600 and 601. He also served as a flight test engineer. Fred received his aeronautical engineering degree from Northrop Institute of Technology. He loved working at TSA on the Aerostar. He never saw the same caliber and knowledge level by the people in any company he worked for after that. He said, "TSA was a unique group. The people knew more than a single specialty. It was a small group and people worked in areas other than their job title. Ted would say, 'This is what I want,' and the task was given to one guy. It was the age of individual responsibility." When TSA was sold to Butler, he did not work for them. However, after Ted bought back the company, Fred would serve as a consultant at Ted R. Smith and Associates and later Ted Smith Aerostar. He would be aerodynamicist on the Model 320 and 360 and the Soaring Star. "The best time I ever had," Fred said, "was just Ted and me together in his office at the Hathaway building in Van Nuys working on the Soaring Star." So next we'll have Dick come up, and Dick Reese come up and kind of describe to you the situation back in the 1965, 1966 timeframe when they were doing the design work on the Aerostar.
Thank you, Dave. So I wish TR was still alive, because 15 years ago, we came up with three people wouldn't be here today unless they done that. So anyway, it's just Miss TR, he was like a father figure. Anyway, I think George Reagan, who just talked to us, really represents what a true entrepreneurship is all about. One person starts a company, has that dream, and sticks with it and makes it happen. What he just did for us is far more important than this us up here. But anyway, I use him as an example of what TR did. I call him TR, some people call him Ted Smith. I don't know how he determined who would call him what, but some of us either introduce themselves as TR, others introduce themselves as Ted. I never did figure out how he determined who was supposed to call him what. I mean, I call him TR. We have another very important person in the art as far as Mike is concerned, that's my son. And he was the first one to fly an Aerostar before anyone else. And what he did, he flew the mock-up Aerostar, developed it, North Korea. So anyway, and right now, as many of you know, he's a very accomplished Aerostar pilot, he's given many of you that tested Aerostar. We're going to be probably cut short of time a little bit. I want to give Dave Duntz the book that he's put together, the Yellow Commander, Star Commander, is unbelievably well done. He is the time he spent putting that book together was equal to the time we spent on designing Aerostar in the first 6 months. It's unbelievable. So for those of you that have not bought that book, and Dave did not ask you to do this, I'm just doing this now. If you haven't bought that book, get that book, because it's an unbelievable amount of detail of Ted's whole life and the development of Aerostar all the way through. So most of the things we're going to be saying is in the book. But let me start off how I first met Ted. That was 58 years ago. Okay? I had read an article. I didn't know Ted Smith from Adam. I had read an article in Aviation Week about this Ted Smith guy that's going to start this new airplane company. And I've always loved airplanes. I built model airplanes when I was little. So I called Aviation Week and found out I was in a space general, in aerospace. So I called Aviation Week, found out the name of the phone number of the guy that wrote the article, called in and found out that when he interviewed Ted, he was at the Santa Monica Airport in a little tiny hangar out there, in a little tiny office. So at lunchtime, I drove out there, which was about a 30-minute drive from where I was. Found him in this hangar, and with him was Phil Kalfas, who ended up being the lawyer for the company. And helped Ted raise the money. But anyway, I found him and started talking to him. And he ended up offering me a job after 2 or 3 or 4 trips out there. Started, actually, it was mid 64. I talking to him, offered me a job to come on board. December 64, but I was involved in one project. So I actually came on board in February of 64, so when the company just started. So we started out with about 6 engineers, about 4 engineers initially, and then built to 6. And eventually, after 6 years, we built about 12 or 13 engineers. That was it. And we had the shop in the back. We started out designing the airplane with a scratch paper. TR had put together a notebook defining the airfoil and surface configurations and so on. So we just started from there. We designed everything from the bare scratch. There was a team effort. That's, as I'm sure all of you are aware, they can't do things by committee. If it's done by committee, you can end up with nothing. Or you end up with something that's not going to work right. So it was all done by individual efforts. The people that TR chose were basically entrepreneurs in their own right. They were very dedicated to what they were doing. They loved airplanes, and they loved what they were doing. So we worked together as a true team, and not committee. Everyone respected each other. No one was better than the other person. We just worked together very, very close to TR. us and oversee us, but if we give up an idea, unlike other people like the builder, for instance, T.R., if he thought it was a good idea, he would accept it and run with it. If he didn't, it was a good idea, he would question us further. But he let us go on our own and let us charge ahead, which was, I think, one of the reasons the company was successful also, that we were able to do things in such a short period of time. So after that, at the design, and as was mentioned, we had a shop right off. This was only a 12,000 square foot building we looked at. So it's a small building. It's a shop right off the engineering department. We built a full-size mock-up of the twin engine. TR had already built a mock-up of its single engine. We built a full-size mock-up of the twin engine. And we started fabricating the first parts about 3 or 4 months after design, and we first started on that vertical horizontal conversion of stabilizer, and hand built everything, including the ribs. We even made the form blocks to form the ribs on, and when doing so, you have to make the form blocks so that when you're bending the ribs, and we hand bend all the ribs, you have to over bend them, so when you heat treat, it's certain back out again. So all that was taken into consideration when we're doing this. And this is not TR teaching. We just kind of did this on our own. I don't know where this came from. We just were creative. So we send the ribs out to Douglas and the teacher didn't come back. So we literally hand built the first of the aircraft. Everything. TR bought the milling machine. He bought the shears and brakes and the drill presses. They do it like your own brakes. And the drill presses, they do it like your own home shop. It wasn't that more sophisticated your own shop. It was about a bunch of fancy equipment. As mentioned earlier, everything was done without a computer, the whole slide rule, a whole drafting board. So we hand built everything. As I mentioned, we built 3 aircraft, the first 2, the blue one and the white one later on, actually at the same time. And the static test, as we got in the static test, we actually designed and built the building out in back of us. It had the whooping trees and all this kind of thing to do the static test. And later on, we built the tank for the start the pressurization of the pressurized aircraft. And so it was a fantastic thing. When we got all that part done, the aircraft were built and Ron Smith came on board. And we hauled the airplane to Van Nuys Airport down the street. Which is in the book. I was sitting on the cockpit, and Ron Smith was driving the pickup truck. It was about 2 in the morning, and bars were starting to close. And this is a twin-engine airport in over the 2-lane road. And I could see the expression in the face of the people driving the car. They were looking at this thing. I'm sure they stopped drinking after that. So we hauled it to the airplane to a little tiny hangar because the facilities that Van Nuys hadn't been built yet. So we hauled the airplane to a little tiny hangar at Van Nuys, and we did all the flight testing from there, and the finishing of putting airplanes together, but finishing of the details. And started the flight testing in October of '66. So it just from February of '65 to October of '66, we had the airplane, 3 aircraft built, designed, and in the flight test. And the first flight test, we had to fly to Fox Field because you couldn't, experimental aircraft, you couldn't do the first landings at Van Nuys. So we had to fly over there. So we flew at Fox Field and landed and did takeoffs that are 3 or 4 of them. And then got a certificate from Van Nuys to fly back there and make full landing. And then we continued from there. So it was a very quick and very efficient one because there was just a bunch of when I say very few, it was just a handful of guys, both in the shop and engineering, that were just so dedicated, it made it work. And that's why startup companies do work. It takes people that are just really enthusiastic and love what they're doing, working 24 hours a week, 5 days a week. Anyway, it's been my pleasure to work with a company one of the things that we did do, I believe we were forced to have wet wings. And part of that was because of our structure. With as few ribs in the wing and heavy skins allowed us to be able to seal the wing quite easily. So I believe we were the first ones with the wet wing. Also, I believe we were the first to turbocharge. Other aircraft have been supercharged, but we were the first to supercharge. Ray J had done that on different people's aircraft, but we were the first production airplane to supercharge. And with the Ray J supercharger, if you're not aware of those came from, the turbines came from cat tractors. And then went to the Indianapolis race cars, and that's where Ray J, they used those to put in airplanes. So we went through all that development. And this is all during this short period of time. None of us knew anything about this. It was just being creative, I think, and interested in what, loving what we're doing. And again, TR really touched as well. Pretty much, if he felt we were going down the right road, he just let it go. It made it much easier for us to do it that way. Anyway, I'll stop here. I could go on forever, but I'll turn it over and let you handle whatever. Hopefully, we can answer any questions at all. But it's been, bear in mind, 57 years ago for me. I spent the first 5 years, and then after that, I left and joined another company, startup company, and started another business. So you people know a lot more about Aerostars than I do at this stage. It's unbelievable. Flying back here with Eric in the Aerostar. It's been 30 years since I've been flying. I flew quite a lot. I was going to mention something else. In the military, I got a special assignment. Dave mentioned it, first class jets. So I was stationed in Wichita, Kansas. Wanted to instruct and teach the potential B-47 pilots how to fly jets. SAC had just been set up. But the other reason that we were there is because of the huge thunderstorms. And our job was to spend 4 hours a day, 5 days a week for 3 years doing nothing but board in the thunderstorm. And we were young, I loved it. But the purpose, it was a research program to see if aircraft could really take these thunderstorms. They're flying a very tough airplane, a very ruggedly built airplane. Don't let that snow you into thinking you can fly into these big thunderstorms and survive. You can't. In fact, just west of here, Oak City, if I remember correctly, about 1954, the B-36, which is the big 6-engine pusher with 2 jet pods out of each wing, flew in a thunderstorm over Oak City, and that airplane was completely disintegrated. There wasn't even a whole engine. The crew built out, all I do remember specifically is the pilot built out. He was in that thunderstorm with his bailout mask on, but for 45 minutes. And you're well aware, I'm sure, that thunderstorms are made up of a whole bunch of cells, like a bunch of supercells together. So he was ripped off to one cell, they would pick him back up again, collapse the chute, pick him back up again. And then the chute collapsed and we just shift over the next cell and take him back. So he was in that thunderstorm for 45 minutes. His body was mutilated. Most bones were broken, but he survived through it. But anyway, stay away from thunderstorms. It's just, they can kill you. Anyway, I will pass this on over. I'm going to talk about oxygen, but it's make sure you're looking at oxygen. My experience in altitude change and everything else, I used to volunteer to sit in front where I was unplugged without knowing it. If you're unplugged without knowing it, there are no symptoms. And just believe it. There are symptoms if you unplug yourself, which many of I'm sure didn't altitude change. If you unplug yourself, you just feel those symptoms. But if you're sitting up in front in the chair where you don't know you're unplugged, you just pass out. That's it. And bear that in mind too when you're checking pressurization and everything else when you're flying. Because you're flying high performance aircraft. Anyway, I can talk for a minute. Thank you very much.
Thank you, Dick. Well, I've got a few questions here, and I thought the first one might be something that each member of the panel could comment on. And that is, panel, how would you describe Ted Smith? You want to start, Dick? Oh, and use your microphone there, and we'll pass that down as needed.
Well, how many of you have met Ted Smith? Very few, right? He was an unbelievable man. I love Ted Smith. As I said, he treated me like a father. He really did. Ron Smith had not, I was with Ted for a year before Ron Smith came on board with his son. But, I'm sorry. Anyway, Ted treated me like a son in all respects. Sometimes I was dirt. And other times I was super. Well, he treated me exactly like that. He would call and my wife and I said, Sue and Dick, come on up with me, and I'm going to fly up from the Commander to San Francisco and have dinner. We want you to join us. So we fly up to San Francisco with Sue, myself, and TR and Rosita. Have dinner, and then we'd fly back down to our Commander. So he treated me just wonderfully well. However, he had the reason you didn't hear a lot about him in the industry, he had a personality where he could really turn some people off. If he got mad at you, boy, he could really turn you off. So you had to work. He didn't do that to all people. I shouldn't even say this, but well, there's a memorial on Don Mubaugh, who was a minister. TR was not a religious person, but he had breakfast with Don Mubaugh every Saturday morning for all the whole years I knew him. At the memorial, Don Mubaugh, who knew him that well, and there were probably a couple of hundred people at the memorial, many of whom knew TR very well. He said TR was a schizophrenic personality, and that's the reason he could turn. One time he would just be a beautiful person. Other times he would just rip you apart. But he only did this with certain people. I think what it was, he would get frustrated about something and then take it out on, he had to take it out on someone. So he would choose specific people to take it out on. In the first 4 or 5 years at Aerostar, it was Bill Kappas and myself. Bill Kappas being the lawyer that helped him raise all this money. And so that side of it was, I fully understood, but it was tough to deal with, but most people did not see that. But otherwise, he was a very giving person, obviously a very smart person. He was smart in all respects. He obviously knew design. He knew engineering. He knew marketing. He knew sales. He knew manufacturing. I think his only fault was he was too optimistic. He was very optimistic in everything he did. So he would way oversell, as an example, when we first got started, how many aircraft we'd have come off production line. And that turned off our major investor at the time, which was J.G. Boswell. And J.G. Boswell was smart enough. He went around to a few of us in the company and asked us, Dick, how many aircraft do you think are going to be coming off the line? And this was like in October, I forgot what year, but earlier in the game, before the first part of production, where TR said 20 are coming off. I said, you know, we're going to be lucky to have one of them. So he was doing this to try to keep the people that already deposited on money on the but by being over optimistic, I think that hurt him a little bit. If he cut back and been a little more patient, get things through, and have the first buyer wait a little longer, I think it would have been a lot smoother. But again, my love for him is, it is a true love. I love the man. He was unbelievable. Fortunately, I was able to see him actually just a couple of days before he passed away. My wife and I spent take, I love the man, I shouldn't even pass on what I did, but to know him, that was the truth. That's it.
It's on. It's on. It's on. It's on.
Well, I worked with Ted mainly in more of a junior capacity for the first 5 to 10 years of my career with Aerostar. And I could see where he could be difficult at times, but everybody I knew that worked with him loved the man, loved him for his vision, loved for the way that people operate the company. Later on, when I was promoted up to director of quality, we got along well. He's the one that I think pushed more than the rest from my appointment, and I appreciate that for him. And he never, I think, talked very much about the quality aspect of the airplane. Let me do my job and work with everybody needed to get same point. He was more involved, as most of you have mentioned, in the engineering and direct manufacturing, especially tooling area of the airplanes. But he was a great man to work with from my standpoint. Never had any problems. I think most of the other people above me were kind of a cushion for that. And so I had a great time working with him. A few times I worked more directly with him. We always got one fine. Maybe it was somebody was in between us that more the book did for Neil Anderson. Took a lot of that. Dick left, he was in charge of all the engineering, and he was my direct boss then, so there was a lot of coordination that went on together.
Well, I can't say enough nice things about Ted Smith. I think the thing that impressed me most is that one of my first tasks at Northridge was taking some sound data in one of the test airplanes. And I had some experience working with measuring sound and all that, knowing how the instrumentation worked and everything. So I had taken some sound data, and after we got back, a couple days later, I got called into Ted's office. You know, it's unusual for a young guy just freshly out of college to be called into the president's office to explain something that I had, some testing I had done, and it was, to me, he was recognizing that I had an ability or something, and I was really impressed to be able to get to do that. That was awesome to me. And he was always such a nice guy, just nice. And one of the things that really impressed me, of course, I had heard a little bit about Aerostar from reading it in Aviation Week. And when Bill came to the campus at Northrop to interview me, I said, hey, this might be fun. I was interested in light airplanes. I had just recently got my commercial ticket. And I said, I think I would like to go try to go to work for this company. And I had a chance to go back to Rockwell. I had worked on the Apollo project as a technician when I was in college. And I could have got some tuition refund money to go back there. But I thought, and at that point, the Apollo thing was kind of over the hill, so to speak. So I thought, I'm gonna check this out. So anyway, one thing that really impressed me is before I got it, I was a member of the engineering technical staff. There was Bill Leeds, myself, Ken Grosnick, Fred Norstad, and we all worked for Aerostar, and of course we all worked for Dick Reese. But I walked out in the shop one day, and here is this airplane sitting there with jet engine nacelles on it. I thought, man, this is awesome. I have really made a great decision. And I think if there's one thing that I could say that would sum up Ted Smith, it would be this. Some of you may remember there was a Broadway musical many years ago called Finian's Rainbow. It was about a group of Irish immigrants that came to the United States, and they were starting their own community. And one of the lines there was a song from that musical that impressed me. It's called, and one of the words were, "Follow the fellow that follows a star." And Ted Smith was following a star. And because he was following that star, he had that vision. And all the rest of us joined in because we wanted to follow that star too. It was because of his leadership. And from speaking for myself, that job with Ted Smith formed my attitude for my entire career. And I'm almost 83 years old right now. And my entire life, professional life, has been a result of that working for Ted Smith, and there's no way I can express my thanks enough for what he had done.
Unfortunately, I came on board 6 months after Ted passed, so I have no personal recollection of Ted. For 6 months.
Yeah. I happened to be down in Waco, Texas with Ram Aircraft at the time that he passed away. And I'd seen him failing, his lips would be white when he'd come into the hangar. He was working on the pressurized fuselage for the 601 pressurized airplane. And he hired me, and I'd worked at ITT Gilfillan working on the radar after we all got laid off. Worked there for 9 months, and then he kept calling me, reassuring me that we were gonna start this thing. And then finally one day he said, "Come on in," you know. And Dick Padgett, he was in charge of the maintenance of the airplanes, and I was in charge of the production of this pressurized one. And we were the only two in the hangar. And so when Ted Smith, associate, started, people were flying in to have Ted Smith work on the airplane. And it's very, very interesting. And I started working on this pressurized thing. We brought people, number 128, 129, the fuselage. I bought it from Kirkland, brought it up, and we started reinforcing the thing, making 4130 steel frames and stuff. You know, boy, my elbows were sore because we did it all by hand. It was very labor intensive. We didn't have any equipment. Then Ron bought a bunch of equipment from a place in Oklahoma that they used to buy equipment from when they were working on commanders. And so it was a bunch of Chinese and Spanish stuff. But I was doing the welding and the machining, the fiberglass layup, and making the form blocks and templates. I was the liaison between the FAA, my office, and the group there. Every Tuesday, the guy would come down and start going through the templates and the drawings, making sure they looked alike, and then the parts, and we built the parts, we checked those against the templates and the drawings. And we had a good, his last name was Sayer. Anyways, he was very easy to work with because everything we did was the way it's supposed to be done, and you didn't have to fight or arm wrestle. And so he'd come in on Tuesdays, check the things out, and then anything that needed correcting, he'd be there on Thursday, and we'd already corrected it by that time. And prior to that, when I first came to work at Ted Smith's in Winneka, Northridge, I'd been working at Duntz Aircraft in Santa Monica on DC-9s. And it was so, it gives you just thinking about it, it was awful. They had these DC-9s, I mean, it was 18 to 218 working on serial numbers. And I was working on the air steer door. I had a bunch of guys out of the Watts area working there. They didn't know how to do, they didn't know what ruler, they knew what ruler was, but they didn't know scale. Hundredths of an inch was everything, we didn't know anything. And they're laying out rivets and everything, it was really hard to work with them. And one guy, the doublers, the skin was probably that thick around where the air steer door was. And one guy got the jig off center, and that door was probably that far off where it was supposed to be. And all the guys should talk about a panic. They had the engineers come down and figure out what to do with this. I mean, destroying the nose section of the airplane. But I worked there for a couple of years, I think it was, and I finally, they depended so much on me because I knew how to do stuff. And sometimes there was a hole, a tooling hole, and it had to miss a hole in in a frame, and you had to drill a hole like this, so you could drive the rivet, the tail would be away from that hole on the other side, so you put in a rivet crooked. Not everybody knew what they were gonna do with something like that. I used to do that, and inspectors appreciated me. Then I got tired of it. The guys that smoked, they'd go out for 10 minutes and take a break outside the hangar. And so I started doing that because I had to rest them sometimes because they were running me all around doing pickup stuff. And so I go outside there and stand there for 10 minutes, and the supervisor, "Oh, what are you doing out here, Roger?" I said, "Take my smoking break, you know." And he said, "You don't smoke." I said, "I know." Then he knew he didn't have to ask me anymore. And but I worked there for a couple of years. Matter of fact, when I hired in, my dad worked there from 1930 to 1964, 67. And so we had a shop at home. We used to make altitude chambers for some company down in LA. And I was exposed to all this kind of stuff, and drilling holes and shooting rivets and that kind of stuff with welding. And we had equipment at home, a lathe, a metal lathe, and I used to make cannons and rockets as a junior high school kid. So I was doing a lot of weird stuff. But when I saw a little ad about this big in the local newspaper that Ted Smith was looking for R&D mechanics. So I said, "Oh, I'll go try that." So I went over and applied, and they took me in. I was on vacation from Douglas. So my vacation, I spent it at Northridge there. My first job, Walt Stafford gave it to me. It was the tube that goes from the fuel tank in the wing and transfers behind the firewall there. It's an inch and a quarter, I think, and it has a flange as welded onto it. My first job was to build it. So they didn't have any equipment to do this, and it had to have a bend in it. You try to bend an inch and a quarter tube without kinking it. I had to mess around the shop to find some way of doing it. So I went and got some floor sweep, like cat litter, and I stuffed that inside this piece of tubing. And then I put wooden plugs in the thing after I put water on it, and it swelled up. So I could bend a rod, but I couldn't bend a tube. So I bent this thing to the shape that needed, and had the flange welded onto it, and took it out to put it in the wing. It was out in the lab. And I got out there and opened the wing up to put it in, and there was one there. So my first job was worthless. And but it was everybody was just stroking along real hard, running in circles there, doing things. And then I worked all through the shop there. We had, like Dick said, we didn't have the fancy equipment. We just did whatever we had to do to make something happen. The leading edges, I remember, were built down in Douglas and Santa Monica. They bent those 50,000 skins, and on a big break they had down there. And I had some made over in North Hollywood, at a place that did a lot of that kind of thing at a later date because Douglas had gone. But it was interesting working there, and everybody loved Ted and working around him. And he was such a mellow guy most of the time. I mean, if you were straight with him and you were doing what he thought you should be doing, he was fine with you. He only got upset with me one time. I saw him stroking across the ramp from his office. He just walking up there like this and looking at me, and I thought, "Oh, what did I do?" And he got to me, and he was blaming me for something when he was working on that 601 pressurized airplane. And he was wrong. And the other guy that was working in there, he had the credit card for fuel for our own personal equipment, our cars and trucks. I had a station wagon that wore out there. And but I never knew that he had this credit card. He kept filling his van with fuel, and I didn't get anything. And then anybody that knew Ron Smith, he was kind of in charge of this thing, as he sort of did. And he was, I guess I could call him cheap. I would work 16, 18 hours a day, and I was on a salary for 8 hours a day. And there was no benefits for working all that overtime, but you didn't care. You just did it. I mean, you were so enthusiastic about the airplane, you did it. And it was very interesting. I finally started hiring people to help me with that thing. I hired a machinist and a welder, and I got Ed Garcia back from Kerrville. He'd gone down there with the Aerostar program, and when he got laid off, he was a Hispanic Hispanic fellow. And in Texas, you weren't real, didn't have a real good standing. And he and his son were down there, and I called him up to come help me. And he was so enthusiastic. He and his son were down there painting a Foster Breeze. Well, he got out of there so fast, he was up there right away. But all these guys I hired, I paid them more than I was getting. And, but that was the way it was. And like I said, I want to say Ron was cheap, but Ron was cheap, wasn't he?
Raj, I need to move on to some other questions.
All righty.
Okay. You probably know that the FAA does not require an aircraft, general aviation aircraft, to be designed to be fail-safe. If you're not familiar with that term, it means that you've got multiple load paths or multiple structures, such that if one structure fails, you have other structure that carries the load and the airplane is safe. So Ted, in his way, wanted various parts of the Aerostar to be fail-safe. And so what I would like to do now is ask our panel to discuss if they were involved in any of the fail-safe tests and describe them and what the results were. Anybody want to start right with that?
As Dick just said, the fail-safe for damage tolerance for life cycle testing is not required under the original Aerostar. It became a regulation later on. The Ted was very cognizant of the fail-safe approach to the design. So a lot of the parts that he made, especially the major parts like the wing and the major spars, are all multiple spar tabs. And the fitting itself had multiple lugs and such on it, such as one fails, the rest of it takes lugs. And so there's a lot of it in the design. We actually, though, when we got to the pressurized models, starting with the 601P, 4.25 PSI testing, we were doing the certification, requiring the full certification of the pressure vessel, which was only required at that time of the FAA. So we did both damage tolerance and life cycle testing. The damage tolerance testing we did was we went through the fuselage and determined what we thought were going to be the critical members from a loads and stress standpoint. And we made actual cuts of the members, cut them in half, cut them in thirds, depending on what kind of member it was, and then tested it to the limit loads. And then we did that for numerous parts all over the airplane. I think probably 15 or 20 cuts on the fuselage members, and then did the test over and over again. In which case we could have got by with doing one at a time, repaired it, and then done another one, repaired it. But we left all the original cuts in and kept making the test over and over again. And then we went on to the damage cycle testing, where we're just running the test cycles of one pressurization and then two pressurization and so forth. And we left all the damage tolerance in. The only thing we did is we covered them up with like tape or sealant to keep them from leaking, that they were a member that was subject to the leak on the airplane, to keep it from losing all its pressure while we were running the test. And we ran all the tests with both the fail-safe test and the pressure cycles up into the 25 or 30,000 cycles on it. But by the time you convert that to hours or cycles and the number of safety factors you put in, I think someone made 10,000 cycles inspection. None of them requires to be changed on the airplane. The only ones that have an actual life are the windows and windshield. And that's because there's no fail-safe members in there. So they had to go with the damage life cycle, because fail-safe requires you to be able to present damage to the part and still take load, which if you only have one member, you can't do that. So we ended up having life cycle hourly testing on the airplane for windshield windows. And that was pretty much all the tests we did, and we did it over as part of Aerostar Aircraft Corporation, when we got the pressure to 5.5 gauge. So we did all that they retested everything all over again. That's why the life cycle started over again, and the windshield window colors are reduced because of inspection requirements, checking of parts and pieces on the airplane as part of the increased pressurization. Some pieces have changed out, a couple of pieces were changed on it. A lot of it was cycle testing and gas.
That's it. I was involved in the pressurization testing of what was called at that time the Model 620 airplane. And we had the fuselage immersed in an 18,000 gallon water tank. And we would fill the tank and the fuselage with water. And I had 110 strain gauges mounted inside that fuselage. And what we did, as you all know, the fuselage is egg-shaped, and when you pressurize an egg-shaped fuselage, the sides are going to try to bulge out, the top is going to try to come down. So that means you've got compressive loads at your elbow, and you've got tension loads at the top. But to know where we were going to put the strain gauges, we had to do something different. We took we sprayed on a brittle coating material. And I was doing this, and in order to spray that on, you have to heat the fuselage to about 100 degrees or more to cure up the stuff. And then you get inside and you spray this stuff on the fuselage. And this stuff had carbon disulfide in it, which is very toxic. So I'm inside the fuselage crawling around with an oxygen mask and a bottle, spraying this stuff on. And then after it was dried, of course, we pressurized the fuselage, and this brittle coating, by its very nature, will crack where the stresses are. So sure enough, we had cracks at where your elbow is, and we had cracks up the top. So that told us where to put the strain gauges. So like I said, we had 110 strain gauges in that fuselage, and we filled it with water, which what we would do, we didn't care if it leaked as long as we got the pressure. So we would fill it with water, and we put air in the top to pressurize it to the pressure that we wanted. And one of the tests we had to run, we were looking at 5.5 psi cabin delta P. Okay, that's a lot of pressure. And the FAA regulations require for a burst test, you have to double that. So we actually took that fuselage up to 11 psi, and nothing broke. You have to hold it for 3 seconds, I believe, the requirement was. And then, of course, we did as Bill talked about cycling tests, I did a lot of cycling tests on this 620 fuselage. And what we did, we filled the fuselage with styrofoam blocks to cut down the volume. And I designed a system where we had to cycle flight loads, down bending flight loads, and pressurization loads. And I put together a cycling system that would apply that pressure. And I had a vacuum pump that I was hooked. I had an outflow valve, reduction outflow valve, hooked to the fuselage. And I had a vacuum pump that was fed to that, and I had a timer and a valve. And when the pressure switch got to the right PSI, that valve would open and would turn the vacuum. It would open the switch that led to the vacuum pump. The vacuum pump would work the valve, and it would come down, and the pressure would come down. In the meantime, the hydraulic load, which comes up and goes down fast, that would also cycle. So that was a rather interesting project. It was so much fun. When we were doing pressurization tests, as I said, we had 110 strain gauges, and the system I had set up only handled 10 at a time. So I had somebody in the lab reading the data on the recorder while I was up on the scaffold, moving. As soon as he told me he had the data, I'd switch connectors, and I had to do that for 11 different connectors, and that was a rather interesting thing. That was so much fun. I really enjoyed that.
Okay, thank you, Paul. Let's see here. Somebody mentioned something about the jet, and as probably all of you know, the Aerostar was designed from the beginning to be a jet. And surprisingly, there was quite a significant effort early in the design of the airplane and the build of the airplane to have a jet. So I'd like the panel to discuss how far along were the modifications of the first prototype, which is N54 Tango Sierra. How many of those modifications were made to make the jet in 1968? Now, I do want to say one thing. This airplane was the prototype, very first one built. And right after the third airplane, which was the production configuration 600, was flying, this airplane happened to make a very, very hard landing at Van Nuys, and it was retired to a hangar, wherein it became the jet prototype. So, who would like to address that, Raj?
Well, I'll start off.
Oh boy, microphone, sir?
Well, I like that all the time. The jet really had, we made the very first conceptual drawings of the jet, the underwing jet pods. And that came out, I felt that if we put them back the tail, everyone was doing that. So let's have something new. That's different. So we made conceptual drawings of the pods on front of the wing in place where the engines are. And this was like in 64, or rather 60, end of 65, very early. And we actually went out and started getting the cells fabricated. No engine was available right now, but we were thinking ahead, just this TR thing, we were thinking ahead and trying to get ahead of the game so that when the engine came out, we'd be ready to go ahead and charge ahead. So we did that, and I forgot to mention earlier that the investor, J.D. Boswell, Jim Boswell, got frustrated because we weren't getting the production aircraft off the stats. So he was going for a buyer, and Americans was responsible for in the States today. And Bill Pascoe of Pascoe Steel, who owned a lot of Aerostars and moved TR through that. And American Cement had bought Pascoe Steel, and because Pascoe Steel was almost bigger than American Cement at the time, it was still ragged along. Well, certainly after they bought some, between the Bill Schreiber and Bill Pascoe, they talked the American Cement board into buying that cement. And the reason that happened is because Jim Boswell got frustrated that we get an aircraft off, and he had invested $7 million, so I believe, was very close. He's telling me to get this closer. He had invested $7 million into the company, which in those days was a lot of money. So he felt that he wasn't getting the aircraft that TR promised, and so he wanted to get out. So he was able to sell his portion of that cement to American Cement. And so when that all happened, that kind of stopped because we were running out of money. American Cement at the time had invested, they're going to build a $60 million cement plant back in Chicago. This is during the days when they committed to those bonds, and then the bottom dropped out of the building market. So, but they were committed to bonds, so they had to come up with the money, but there was no market for cement. So they had to start selling off assets in their investment with one of them. So they ended up selling that to Buffalo. But anyway, during this time, that kind of stopped the continuation of any development of the jet. We ran out of money, so we wanted to concentrate on the airplane. Then later on, it was resurrected when I believe I didn't go to move to Santa Maria. it was resurrected there, and then actually, Aerostar Corporation was Corporation, they're the ones that really did the development and built the jet. They started from scratch and really built a beautiful airplane. I filmed that, and it's like flying a D-33 jet. It's just a fantastic airplane. Anyway.
I wasn't involved very much in the jet when it was down at Test Aircraft. I was mainly involved in production aircraft and certification, getting all the airplanes certified and out the door. I saw the development work going on occasionally when I was back and forth to Northridge, but other than that, I wasn't too involved in it. I was more involved up at Aerostar Aircraft when they started actually working, building a flying airplane up at Coeur d'Alene Airport up in Hayden Lake. And as Dick says, it's a beautiful airplane to fly, and it would have been something that I'm sure they would have been very proud of. So, you know, it's finally come to fruition, or at least from a flying airplane standpoint. Hopefully we'll get it into production one of these days.
Okay. All right. We are a little short on time, but we're going to go another 10 minutes or so. And one last question for me, and then we'll open it up to the audience. All of you are aware of the Aerostar 800 for the two 400-horse engines. You know, a lot of times we show that photo of the Aerostar 800 in Stars and Stripes during these conventions, and you can hear the drool falling on the floor. Well, it really did fly, and these gentlemen were involved in the construction and the test of that. So I'd like the panel to answer the question, what were some of the problems of the Aerostar 800 with the 400-horse engines?
One of the things we discovered with the 800, we had a cruciform tail configuration on that, and which was really kind of cool looking. But we noticed that when we were landing, I did a lot of flight testing in the 800, and what would happen as you're about to flare the airplane, the aft fuselage would blank the horizontal stabilizer and elevator, so that you thought you had a smooth landing going on, and all of a sudden, you're on the ground. And that was one of the effects of that cruciform tail. But as far as the 800 is concerned, that thing was like a rocket. Those 400 horsepower engines, it was just fantastic. And I enjoyed flying in that so much. But it was a lot of fun. But that was the only problem I was aware of. And of course, we put a fuselage plug in that to extend it. And if we were looking at, one of the things you look at, of course, is aft CG approach stability. And we were right on the margin of that, not having enough elevator power. And we were considering it when putting in aft plug. Anytime, I spent many years at Boeing, okay, and when they do a stretch on an airplane, you put in a plug forward of the wing and aft of the wing. And we had put in a plug forward of the wing on the 800, and we thought we were going to have to put a plug in the aft section. And what happened is, as I understand it, there was, management was concerned that the sales of the 800 would take away sales from the 600 series airplane, and that was the reason that the project was abandoned.
I was around when Piper started in earnest making the 800, and they made a lot of changes from the production, from the prototype. The big one was they were in kind of a tiff with Michael trying to get the cost down, so they were going to go with Continental geared idle flight planes at the time, they were 25 horsepower, which was aesthetically it was terrible because those engines are huge. You really couldn't even see out the windows. They were just monster nacelles. But they were working the design of that. And they also, from the data that was taken on the prototype, they had determined that the horizontal stabilizer and vertical were not big enough, so they moved the tail or the elevator and stabilizer all the way to the end of the empennage and beefed all that up. And they also, during that time, they had the issues with the fuel system. We went through 40, 50 hours of flight test, proving to the FAA that the system was just fine, just leave it alone. And so they were making the wings into cruise wings, so you could essentially do double crossing and keep the fuselage bag for turbulence. They ended up making the airplane that you could drain the wing actually at a 30-degree bank. It was all it would cruise or in a level fashion. So those were the big changes to the airplane. They had a prototype that they had mocked all that stuff on. I don't know what happened. It would have been a very fast airplane. So.
Okay. Thank you, gentlemen. We'll open the floor now to questions. Any questions to ask the panel? This is like Stump the Band. Let me run out there and give you the mic.
Can't buy Dave's book if you don't have it, because it answers everything.
Well, first off, gentlemen, I just wanted to say hello to all of you on behalf of my dad, Charlie Hunter, who's not with us today. I mean, he's with us. He's just in Rhode Island getting ready to go on a trip. I don't mean that way. Yeah. And it's very interesting, by the way, to hear stories of Ted and his relationship with Ron as a guy who is the son of and works for a guy who was a very strong student of Ted Smith's, I can tell in many different ways. So I look forward to learning a little bit more, Mr. Reese, about maybe how that relationship went over a drink. The question I wanted to ask the panel, and thanks everyone for being here, is I know you love this airplane. I know you helped make it happen. If there's one thing now looking back with everything that you've learned, that you said, you know, if we had just done that, it would be even better. I was wondering if each of you or any of you had some thoughts on something that maybe if we had had something a little different, or if we had just thought about it differently, would have made the great airplane even better.
Well, the airplane itself, I think is fantastic, but I think one thing that would have made it a much more successful airplane into the industry, if Ted hadn't been so aggressive in wanting to get these airplanes off the production line immediately. Unbeknownst to Ted, he was in Hawaii. I got together my whole engineering team and assigned each guy to each station in the production line. I had nothing to do with production. And we went after work, and the production people were still there, and I had each of my guys ask each station, what would you do to keep from having all the problems at your station, so when the airplane gets off the line, they have to do all the darn fixes, which was costing a fortune and slowing everything down. So we got all those answers, and I put that together and sent that to Bill Martin and Eric Smith. And they said, well, I wish we'd done that thing a bit quicker. But if we'd just done that, what I can do is send one airplane through, get the problem solved at each station, and then start the line through. If we'd done that, I think we would have, and I'm not trying to take credit for anything here, this is just common sense to me. If we had done that, I think we would have then been able to produce airplanes at a much faster, well, produce them then at a much faster rate and done completely rather than do all the fixes afterwards. And I think that just, that ruined what was going on. And if we'd done that initially, we would have been way ahead of the game. But it's so easy to want to charge ahead and get things done regardless, and it just catches up with you big time. Anyway.
Unfortunately, our time is up, and I would like to remind all of you that all of these gentlemen will be with us for dinner tonight and all day tomorrow. And